Okay.
The stage is yours.
Okay, cool. So hi everyone. So this presentation is called What the com-lihaoyi Platform Needs from Scala. My name's Howie. For those of you who don't know me, there are basically like two halves to my professional career. One, I've been doing a lot of open source Scala work. So Ammonite REPL, mill build tool, bunch of upickle OSLib libraries in the Scala toolkit, fast parse Scala tags, blah. Probably few of you know the work I've done professionally. So I've written Scala at Dropbox. The only Scala at the company was the Scala I wrote doing static analysis in Java, in JavaScript and Python to find bugs. At Databricks, just Scala shop, I had a lot more Scala there. We did build tooling, CI systems, multi-cloud testing across Azure, AWS, Google Cloud, GitHub workflow automation. Some of these really interesting things, like for example, we had problems with Jenkins and we couldn't figure out how to make Jenkins stop falling over for 12 months. And after 12 months, we gave up and just wrote our own CI system from scratch using the com-lihaoyi stack, so Cask, request, Scala, OSLib, and so on. Since I've left, my colleagues or ex-colleagues have told me that now it's managing about 200,000 cores at peak hours, like 3 p.m., 4 p.m. US West Coast time. So we also did. So this is kind of the things that I've been working on professionally, and this is where a lot of the inspiration for the open source libraries comes from. So yeah, you have this nice little JSON library, nice little request library, but where it came from is these like huge burning trash fires of mess of production code, of legacy code, as you're trying to take all this stuff and make it work in a really fast changing environment. So today the agenda is we have 4 sections. First, for those of you who don't know, we'll do a quick tour of the platform, why this platform exists. We'll go into deep about how this platform libraries use Scala today and what we need from the language going forward. So first, what is a com-lihaoyi platform? So a subset of the libraries are here on the left. You can see that I put the date where the library was first published on the far left. So these libraries have slowly been accreting over the past 12 years since I started using Scala in 2012 as a college student. From my HTML templating library that I used for a small side project that in college made $2,000, all the way to the Scala SQL database query library that was released in 2024, just earlier this year. They originally were under my own account. They've been since moved to a GitHub organization. There are a few people who have committed access, so it's not just me. And I've in fact I've disappeared for a year or two while I was working at Databricks and other people helped keep the ship running. About 20 million downloads a month on Maven Central, so people really don't cache things on the CI bot, so the CI workers really download a lot of artifacts. It's largely self-contained, so these libraries depend on each other, and they generally don't depend on stuff outside. So you won't look into a library and find this akka under the hood, a huge thing. You won't find it's like cats under the hood. They really depend on themselves and the Java standard library. And it's really a finite amount of code. Like it's a few thousand lines of code. You can read it in an afternoon if you really wanted to. So we can do a quick tour. So first you have Scala tags. You write function calls. They turn to HTML. You have fast parse, which is a parser combinator library, very similar to the Scala one, but I think the current number is like 400 times faster, some number like that, due to a bunch of clever things that it does. utest, which is a small testing framework. upickle, you serialize and deserialize stuff to JSON or message pack. The Ammonite REPL you might have used. Source code, which is a handy little library to put like implicit line numbers and source file names in your code. So if you have a log statement, the log statement can automatically capture where you're logging it, so you can go and delete the log statement later when you're done. You have the mill, which is a build tool trying to replace SBT as an alternative. Pretty printing, preprint, which is a pretty printing library, which lets you put your render your Scala data structures in full color and with nice vertical, horizontal layout, so you don't need to like scroll left and right to figure out what on earth your data structure looks like. You have OSLib, which is a file system subprocess library inspired by Python's OS library. Request Scala, carbon copy of Python request. It does the same thing. It will. Cask, which is a web server inspired by Python Flask. Main.args, a CLI library that was copied into Scala 3 as a main annotation. And Scala SQL, which is similar to Quill or Slick or the other Scala SQL libraries, but generally less powerful and less sophisticated, but easier to use. So that's a lot of stuff. Probably none of you have used all of them. I have not used all of them in production. Like Scala SQL is pretty new. Previously, I was using Quill for my database access. And this gives you a flavor of what this library's com-lihaoyi platform is about. So it's basically self-contained. You can, and I have, written large-scale distributed systems using this platform. You can write programming language interpreters using this platform. You can write API clients using this platform. You want to do a GitHub issue migrator bot? Well, you have a JSON library, a HTTP library, and you're done. You want to write a web server, you have JSON, web server, HTTP client for testing, maybe you need a SQL library. So you can basically do most useful things you would need to do using this platform without needing to go dig around the public internet to find random libraries to pull in, which is kind of nice. And all of these libraries generally work well together. So the next section we'll talk about is why this com-lihaoyi platform. Why should I care about it? Why should I care about it over using the other libraries, using CATS, Akka, Zio, whatever. So to give an illustration, imagine you're in an interview and someone asks you to write a Wikipedia web crawler on a whiteboard, a standard interview question. If you haven't done it before, you should, because next time you find a job, someone definitely will ask you. So you need to make a HTTP request. And in traditional Scala, before com-lihaoyi Akka was popular, this is what you need to make a HTTP request. You first need to import actor system, import some DSL stuff, make your actor system, make an execution context from actor system, then import some more DSL stuff, then you finally can make the request. Okay, good. After you make the request, you need to import more things, and finally you can on-complete pattern match and get your HTTP result. So if you're at a whiteboard trying to do an interview, you're not going to write all this on a whiteboard. This is crazy. You would probably write something like this. And this is exactly what the com-lihaoyi ecosystem aims to let you do. It's meant to let you write executable pseudocode, so you don't have this translation of, I'm meant to do this, and then write a huge ream of boilerplate to do the thing you're thinking of. You just write the thing you're thinking of. In this case, request.get, you get the response. Similarly, if you, let's say, want to write a command line tool, and you're telling your intern, okay, here's a signature of the command line tool you're meant to fill in for me. I give you the arguments and tell you what you're meant to do. You implement it. In traditional Scala, you would start with a config object with some default parameters. You create an O-parser builder. You then create a parser that imports a builder. It uses O-parser to sequence a bunch of things. And then you would have the O-parser to parse to generate a parse thing that you then for loop over the parse to finally get the values you want to actually do your thing. And again, like this is, if you give this to an intern fresh out of school that doesn't know Scala, they're probably just going to drown. Like, what on earth is this stuff? If you were writing this on a whiteboard or on a piece of paper at your intern's desk, you'd probably just write the signature of what you want the command line tool to take. You'd say, okay, maybe call it run. It takes foo, which is a string, num, which is an int, boolean, which is, say, a flag. And that's it. That's what you would write to give your intern. Your intern can understand this. Doesn't matter they know Scala or not. And again, this is exactly what the com-lihaoyi libraries let you do. In practice, you need a bit more than that. Like you might need to annotate it a bit. You might need to actually call it and pass in arguments. But apart from this small amount of decoration, you can write what you're thinking of in your head. You can write what you would have written on a whiteboard or on a piece of paper. You actually write it in your code, and it runs. Like it's executable pseudocode, very different from the traditional Scala style you see on the left. So the point of the com-lihaoyi platform is you can turn this, which is honestly just as verbose as the Java code that people like to laugh about, into something like this, where you write basically the minimal amount of characters on screen, or minimum amount of logic to really express what you want to do, and nothing more. Like we take care of the rest. You want to have a command line argument tool, you write the main method, annotate it, you're done. You want to have a web server, you write the signature, what parameter it takes, URL, done. You pickle write, pprint log, and you get the log message, you make the request, call subprocesses, write a mill build task. All of this is very kind of minimal in terms of you don't need to write all this extraneous implicit imports, factory builder kind of rubbish just to do the thing that you wanted to do. And the com-lihaoyi libraries are generally easy and not simple. So the code here on the left actually expands via a macro. Parser for methods is a macro that expands into a code here on the right. And the code here on the right actually looks very similar to the code we saw earlier. Like, it's actually basically the same code, it's spelled a bit differently, but it's basically it passes and creates the same data structure. So it's not like we are magically making the complexity go away. We're just wrapping it nicely and putting a ribbon on it so you don't need to dig into the internals every time you want to read the code or see what it's doing. Lastly, the interesting thing about the com-lihaoyi platform is that it pushes complexity down into a Scala language rather than building it up. So normally you have your normal Scala language, your methods, function calls, parameters, default values, and so on. And you have two options, right? Let's say you want to have command line argument tool, command line signature. That's not a method call. That's not the default parameter. It's different. So your two options are either you build something on top of Scala that models what you want, or you kind of squeeze it into your Scala function calls and Scala signatures and Scala default parameter values and make it kind of force it to represent what you want, even though it takes a bit of squeezing. And part of the value here is that when you squeeze things into your tools, it means that when you squeeze things into a Scala language, it means that anyone who knows Scala can understand it, including things like your IntelliJ. So for example, over here, we have two examples. On the left is the mil build file. On the right is the SBT build file. In SBT, you ask for documentation of a task name, and it cannot give it to you. Why? Because the documentation is a string. The strings are not typically documentation in Scala. You need like doc comments or Scala doc comments for documentation. So IntelliJ will seize this library dependencies. It knows where it comes from, but it doesn't know that this magic string is actually documentation to give you, because the string, and in fact most of SBT is kind of built on top of the language as this additional abstraction. With mil, you look at def IV deps, and IntelliJ immediately can give you the documentation, because the documentation is the Scala doc. And yeah, we do a bit of magic to capture the Scala doc and provide it to you at the command line at runtime. We do some other magic to kind of make this work. But the magic is transparent enough. Your editor doesn't even know that magic exists. Editor can treat it like normal Scala code. On the left, you can see there's this override symbol here. You can jump to the overridden versions of this task in mil. And as far as IntelliJ is concerned, it's just a normal method call. And that's because we squeeze the whole idea of a task build task graph into your method call graph, so IntelliJ is able to understand it. And the same applies to humans who are able to see this and generally understand what's going on. So that's why the com-lihaoyi platform exists. Next, let's talk about how we use Scala today. So the com-lihaoyi platform loves Scala, and it perhaps loves Scala more than anyone in this room does, including like Martin and Sebastian and everyone else. And I'll talk about why. So we use vals, vars, defs, lazy vals, classes, traits, case classes. You know, some people hate vars, some people don't like case classes because they're not binary compatible, but we take everything. We target all platforms where plausible, JVM, JS native. We love using default parameters. If you go to some of the old linters, they say don't use default parameters. And you know, there are reasons why you don't use them, but there are also reasons why they're very nice, and we do use them. We love both implicit parameters and implicit conversions. We do use monads and applicatives and other things like that where appropriate. Higher kind of types are used in Scala SQL. We use macros. We use macro implicit parameters and macro implicit conversions, and we use them extensively throughout all these libraries, and I'll show you how later. We use Java reflection, we use compiler plugins, we use JVM bytecode analysis. Some things we don't do much. We generally don't do much currying. So currying is like a thing in Scala. Maybe it's more popular in Haskell and OCaml. But my impression is that most programmers outside the pure functional community aren't really comfortable with currying. Like having a whole bunch of consecutive parameter lists looks just weird to people. I know it looks weird to me. And so we do use currying sometimes, but generally quite sparingly. And we try to minimize it where possible. Not always possible, but we try to minimize where we use currying. And lastly, we don't subclass case classes. We are not savages. So yeah, you saw all this nice code we saw earlier, right? So easy to read, so easy to understand what it does. But when you actually look at what on earth we do to make this work, it's full of these crazy antics kind of behind the scenes. We have fake annotation macros because the real annotation macros don't really do what we want. We use implicit parameters, conversions, and the macro equivalents of both in order to make all this work. And if you look at the mil build tool, there's this long laundry list of crazy hacks in order to provide a great experience. And by and large, no one outside of me and one other guy knows any of these hacks exist. They just use the tool and they think it's great. But in order to provide the experience that they like, we need to do all of these things, and we'll talk about them later. First, main args. So I told you parser for methods is a macro here that expands onto stuff on the right. So this annotation, it looks like an annotation macro. It's just a normal annotation. It's not actually a macro. What happens is this parser for methods call looks at these methods, looks for things with the annotation, and then generates metadata based on that. So I call them fake annotation macro. It's not really an annotation macro, but looks like one. And then we use implicit parameters here to pick up the implicit, like how do you parse a string from a command line flag, how you parse integer from a command line flag, and so on. So far, not so bad. Cask, again, initialize is a function that takes the implicit macro parameter. The implicit macro parameter expands into this, and actually this sets it to a local variable or member variable field. So it's not, there's a bit of mutable state here. There's a var, there's a macro implicit parameter, there's implicit conversion for the return type. So return type is actually a response.data type, and we use implicit conversion to convert the string to it because you can have multiple return types, maybe returning JSON, maybe returning a file handle that will be streamed. In order to support all this, we use implicit conversion using the so-called magnet pattern some people have called in the past. Upical, so case class foo, implicit val writer, and I use upical default.write. So write takes a writer as implicit. This gets materialized here. Writer expands to a kind of case class writer subclass thing that ends up writing out the fields manually. So we could use the more abstract things like the mirrors, but we do it this way because it's more performant. We kind of just directly generate the code that does what we want, and then that lets it be inline, monomorphic, nice, fast code. So again, macros, implicit parameters in multiple places. For example, there's one implicit here for the top-level writer, but also we implicitly resolve writers for the individual fields like int and string. And then that's what allows us to provide this seamless experience. Pretty print. You pprint.log, it says file Scala line 1, 2, 3. It tells you the expression that you printed, and it tells you the result value. So this result resolves one macro implicit conversion in source code.text and two macro implicit parameters in source code.line and source code.filename. These then expand into actually constructing the source code.text, which then passes in the string at runtime to the function because we need the string to print it. And it also passes in the line number and file name to the function because we need to print those too. And that's how at runtime we're able to get all this useful metadata to make pprint.log convenient. Like I'm sure all of you have done the print line x equals x, print line y equals y, and keep duplicating x and y, and z and equals z. And pprint just automates it for you, but we need to use these implicits in order to make implicit macros in order to make it work. Request Scala, this one is maybe the simplest of them all. It just uses implicit conversions like the so-called magnet pattern. So you can pass in streaming. Over here, when you make a post request, you can pass in the data as a streaming JSON blob. You can pass in the data as a file you want to stream off disk, and we can implicit convert it into a request blob that has multiple ways of pushing the data into my HTTP request. OSLib. So this is an interesting one. It was relatively recent. So the most interesting thing here is how we generate the paths. So so the std out. So what I'm doing here is I'm calling grep for the string data on std in from some response. Maybe it's a request response, HTTP response. And I'm taking the std out and directly saying, okay, pipe the std out to this OS process working directory folder out.txt. So it looks easy enough. And you can write this in a few ways. Like you can say folder/out.txt separately. You can say folder out.txt as one string. You can say ..folder out.txt to go up one level and do it. But some things don't work. For example, we say that we only want you to use kind of normalized paths here. We don't want you to accidentally put double slashes where you didn't expect it, or accidentally put a dot where you didn't expect it, because in the end, all of those combine to the same simpler path segments. So might as well use a simpler version. And most interestingly, we don't allow dynamic path segments to have multiple segments, or dynamic path like chunks to have multiple segments, because that is a That's generally a security vulnerability if these dynamic segments come from elsewhere. Like someone might do /root/password file and get your password to return somewhere. So we want to force you to explicitly say, if this is kind of dynamic input, where dynamic is for these purposes just defined as not a literal string, you have to tell it whether it's a absolute path, a relative path, which may contain dots, or a subpath which does not contain dots. But if you're just passing in a literal string, we don't want to force you to put os.subpath over every single literal string because you can see the literal string in front of you. It's trivial. So we have a macro implicit conversion that does extra validation to say, if you're a literal string that's properly normalized, that's okay. If a literal string that's not properly normalized, hey, well, please normalize it. It's a good practice. I don't randomly use different ways of writing the same path. And if you're a non-literal string, please explicitly tell me what this is so that I'm able to safely do it and I don't end up like leaking your root password to everyone who asks for it. So lastly, we have mil. Like I said, mil does the most magic. Over here is kind of a snippet. I have IV dependencies equals a sequence, IV interpolator, Scala org, Scala reflect, Scala version. There's some Scala doc up here. And then from the command line, I can say show the IV dependencies. I didn't left that out for now. I can inspect the IV dependencies. It tells me the file name, line number, name, tells me the Scala doc, both the overridden Scala doc and my current Scala doc, and it tells me the inputs of Scala org and Scala versions. So if you're like trying to figure out what my build is doing from the command line, which is often what people end up doing, you get all the metadata that's normally available only in source code, but now we have it at the command line for you to kind of poke at it, debug at it, and figure out, kind of tell yourself what's going on. So how does this work, right? How does this Scala doc comment from up here end up as a runtime string over here? How do these Scala identifiers, i.e. dep, Scala org, Scala version, end up as in my actual text output? I need to get identifiers at runtime, which is normally not allowed. And answer is the stuff on the left expands into the stuff on the right. And it's a bit of a mess. So you have, just going through it, we have build time code generation to wrap all this stuff in a nice wrapper so you can put top-level definitions. This is necessary in Scala 2 because Scala 2 doesn't allow top-level defs. It's still necessary in Scala 3 because we want the top-level wrapper object to extend some base class in order to make this work, and so we still need to wrap it even in Scala 3. We have a compiler plugin that grabs the Scala doc comments and puts them in a annotation, a Java annotation. In Scala 3, I think there's a nice API to get that. In Scala 2, we literally take the source location and start counting characters until we find the end of the comment and put that into the annotation. We then use Java reflection at runtime to fish the annotation out of the method Java lang reflect method object, so we can use at runtime. The def here is actually a fake lazy val that we memorize, and the reason we do that is because lazy vals have this weird thing where you can't call a super lazy val when you override it. I don't know why. This was a problem back in SVT.7 back in 2009. It's still a problem now, but we fix it. We just use a def and we make it a fake lazy val by memorizing it with some key. There's a macro implicit conversion that takes this seek string thing and turns it into a zip map operator. And I don't know if any of you are familiar, but zip map is kind of like you map, but instead of mapping one thing, you map two things. So my normal Scala expression turns into this applicative functor zip map thing. And this allows us to construct the data structure rather than evaluating immediately. And this is what allows us to say, hey, okay, now that I have this data structure, I know I can ask the data structure what my upstream inputs are. It's no longer just an opaque method body that's evaluated or not. It's kind of, I can look at the graph and evaluate it in different ways, including asking about it. Yeah?
Question, where does the t.zipmap, where does the t come from?
This is just an object called t. We renamed it task in the last version. Mm-hmm. Yeah, it's just an object. Okay. Then source code line, source code file name. These are macro implicit parameters, very handy. We have normal implicit parameters. And the last example I'm going to show you is we do JVM bytecode analysis using ASM library. We compile a code, we take the class files, slurp them up, process them, and do clever things. And let's see what that is. Over here, I have a minimal mil file, okay? So I have object foo extends module. Oh, it's a bit hard to see. Yeah, let me zoom in. Okay, zoom in here as well. So, I have bar, which is the input file. I have, this is bar.txt, which I have down below. I have a helper method. This is just a normal method. It reads some file that you pass it and puts out the lowercase version. And I have quux, which is a task that depends on bar. It calls a bar to get the value of the input file. And then it calls a helper method on the input file. Okay, so then in this case, it'll read the file, make it lowercase. So when I show the value of foo.quux, foo is the object, quux is the method of the object, so foo.quux gives you the value. It shows, okay, newer contents of bar.txt, but with the capital letters moved to lowercase. So that's straightforward. If I change the input file, you'll see that now it also prints recalculating quux because this bar got invalidated. So therefore, quux needs to recalculate, and therefore it needs to revalidate this whole block, and therefore we print this out again, and now the printed value has the 3 exclamation marks I just added. Okay, so but what if I change the code representing inside quux? So this also forces it to be reevaluated, and this is something that other tools do to varying degrees, like SBT just doesn't reevaluate stuff often when you change the code, which can result in some inconsistencies. Mill used to, whenever you change the code, conservatively wipe out all the caches because it's JVM bytecode, right? Like anything could happen when you change the code. But that's not actually true. Like we can actually analyze the JVM bytecode and determine what happened. So for example, if I add new lines, it does not reevaluate quux and run the print line. I could add a whole bunch of new lines, change the formatting, doesn't reevaluate. If I change this to lowercase to uppercase, you see now it does, now it does reevaluate quux and print this logging statement in the body of quux. Yeah, so helper is a normal method. There is nothing at runtime you can do to kind of figure out what your method implementation is. Like it's just a normal method. Doesn't return a monad, doesn't return a wrapper object, doesn't return its hash or signature. And what we end up doing is we do bytecode reachability analysis with a conservative class hierarchy aware bytecode parser. And it's not actually that hard. Like there are papers written on it. The whole implementation is about 1,000 lines of code, so it's not like rocket science. You use ASM, gives you all the method bodies, you hash all the method bodies, and you crawl the method graph. You do some clever things around like virtual methods. You do some clever things around like things in your upstream libraries. And for example, in the mill's own build, if I reorder one of the IV deps, it only correctly invalidates 17 out of our 8,000 targets in that build. Where previously, we would either have to choose between 0, which is incorrect because it may have actually changed things and I need to invalidate it, or all of the targets, which is very pessimistic because most of them are not affected. So there are some limitations to this. There's some heuristics, there's some shortcuts and whatever we did. But it works surprisingly well, and no one has complained about it, which is great, even though people have been using this in mills for the last 12 months or so. So that's how the com-lihaoyi library ecosystem uses Scala today. Let's talk about how com-lihaoyi wants to use Scala or needs some Scala going forward. The first thing we want is we want this stuff not to break. So like this, we have something pretty good here. So I'm talking to Martin and it uses a lot of crazy stuff, but like if you break one of these things, please give us an alternative. Like we think we have something really good. Like the implementation is nasty. Give us a better implementation, we'll migrate to it. But don't just like take away stuff, because I think the APIs that these hacks have provided is really great. Like the macro implicit conversions will give me the textual contents of an expression, or the macro implicit parameters to give me the file name and line number. All that's really nice. And currently there's no other alternative to what we are doing here. And you look at other languages that do not have this stuff, and they do not have do a better job. So for example, on the left, upickle uses macros. Other languages do not have macros. Kotlin uses compiler plugins, so they break every minor version. Java's Micronaut, they don't use reflection, so they use an annotation processor, which is basically a compiler plugin that runs and expands AST. Java Jackson, which does allow reflection, uses bytecode scraping with this paranamer library that opens up your class file at runtime and looks for the debug symbol to figure out what your field names are in the constructor and uses that to serialize a JSON. And we did use this at Databricks. This does cause problems when you upgrade things. And generally, like, although the macros are bad, the other things that people end up doing are also very bad, but it end up being done anyway. So we need to be conscious of what the trade-off is here. Like, we take away the bad thing, it could easily get worse. So some of the ideas I think I've had, like, people have problems, but many of these problems are fixable, right? So, adding default parameters not binary compatible. One option, which is what the word remover guys said 10 years ago, is, well, don't use default parameters. Another option is if you can make them binary compatible, that's even better. Then you have default parameters and you're binary compatible. Same for case class evolution, like Unroll, this one of the recent proposals, kind of makes them binary compatible in limited circumstances. And you cannot abstract over default parameters, so you end up having lots of copy-paste default parameter lists in all your methods. Well, if you have some kind of unpacked, like what Python does, that could be nice. So generally, I think most of the problems in Scala are real problems, but many of them are fixable with some work. Like, we have the technology. So here are some of the missing features that I would like to use in com-lihaoyi. And honestly, most of these will probably never affect me because com-lihaoyi has to support old versions of Scala, which will not have these features for many years. But hypothetically, what would make my life easier if I could use them? So Unroll, we've already discussed. Name pattern matching, I think this went up with a name tuples proposal, if I'm not mistaken. You can kind of pattern match on like subsets of your things. Yeah, that's great. So you don't need to have 10 underscores after your pattern match. Unpack, what I mentioned earlier from Python, PEP 646. Inline specialized traits. Currently, we do code generation in a few places to optimize performance because using a generic boxes thing that is very expensive. So that would be nice to have for upickle. Keyword only and positional only parameters. So this is something that Python now has, Swift has, and this would be nice to have me constrain how people call my methods. I don't want them to call them in all sorts of different ways. I call them in one way that everyone else calls them, and this would be nice. Package objects would be nice if they were first class. This is something that we started using in Mill. This Swift shorthand thing would be nice to stop importing a bunch of stuff into polluting my local namespace just to have a nice syntax. The structured data literals, Swift has them, C# has them, Kotlin may be getting them soon. Java has them in limited circumstances for arrays. I don't know if this will be a syntax we want, but I would like some syntax. And the last two are kind of just things that say, I would like to have these features without currying. Like, you already can do these things right now, it's just that you have to curry to get them. And I like to have them just with normal parameter lists. So, for those of you who are unfamiliar, unpack would say, previously you say, I've this method applied that takes in 16 parameters, stream which takes in 16 parameters, and one more. So I can't easily abstract over them. Previously, I have to pass in all 16 parameters every time. That's also kind of annoying. Unpack would say, well, I put the 16 parameters in the case class, along with their types, names, and default values. And then I can say, hey, apply unpacks this parameter object, and I can have my stream unpack it together with one more parameter. And at the call side, I can either pass them all in directly, or I can create the object first and unpack them. So this is something that Python recently put in, and it's quite nice. Makes it a lot more convenient to use these direct parameter lists rather than manually constructing trees of objects to pass in every time you call a method. Inline specialized traits, as I mentioned earlier. This is what we do in upickle. We have this buffering lm parser with this lm type, and this doesn't actually exist. We then, in the build file, we go and regex to replace all these lms with byte and char in order to make it fast. And it'd be nice if there was something that was easier to do it for us. Relative hierarchical scoping. So it's nice to put your case class and case objects into a nice tree in nested namespaces. It helps keep your namespaces clean and stops having these huge flat namespaces. But then you end up having to either have these really long constructors calls to pass them in, or you end up just importing all your stuff into your local namespace and you start colliding with each other, and generally not nice. Swift lets you do this. And even Java, in some cases, lets you do this. Like in Scala, you'd have to say case level.low, case level.medium, case level.high. In Java, you just pass in the direct thing. So it's not generalized, but it's nice to have in circumstances.
Java does it because it looks at the selector myvar and says, oh, it's this enum, so we...
Yes. Yeah, basically like target typing.
That's right.
Yeah. Yeah, structured data literals. So, I mean, we already can do this in Scala 3, I believe. You can call new and it automatically infer the constructor for you. But only if you're creating a new anonymous instance. It doesn't work if you're creating a normal instance. And it doesn't work if you're calling the apply method. And like even for especially for things like arrays, Java is actually more concise than Scala. Having to pass an array inside every time I call suppress warnings or call array equals array, something is just annoying. And similarly for things like this, developer is equals sequence of developer equals seek developer, 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 developer. Like sometimes it's useful when it's unclear, but sometimes the meaning is clear and like, you know, I already know this is probably a sequence of developers. I should not need to tell it all this, tell it over and over. Yeah, this is the last one. It's like, it'd be nice if I could do this instead of this when in cases I don't want currying, because not everyone likes currying and having it tied to currying is a bit weird. Yeah, one exception that I think currying is quite widely accepted is this style over here, where you have a function call with a few like kind of configuration parameters followed by a block. So there's something that Swift, Kotlin, I think Ruby has something similar. So that's fine. And so we do need some currying, but it'd be nice if we could kind of avoid it in cases where it's not wanted.
That's because we use this dead-end encoding of default parameters, and it's very hard to change that. But once you would change it, there would be no problem at all. And
Yeah. Yeah. So last thing is that like Scala is different from 2012. Like, you know, all the problems we had earlier are probably not problems anymore. Like if we made async 10x better, I don't think it really moved the needle in terms of adoption. Or we had like the 10x better IO monad. I don't think people are going to care outside of this very narrow niche. What people do seem to care about is this stuff, which is like tooling, compile speed, memory usage, and I don't know whether that many people actually use Scala native, but I think people want to use it. And by tooling, I'm guessing that just means SPT, IntelliJ, and VS Code. I don't think anyone's complaining about Scala format or about YourKit or JProfiler. It's SPT, IntelliJ, VS Code, and so those are the things that I think people say in the community that they want us to improve on. Yeah, so I guess one thing is that I think that the Scala language needs closer collab with the Scala ecosystem. Like it's always people say, oh, you know, we are compiler guys, we don't know libraries, and the library guys also don't know anything about the compiler. So like none of the things cross-pollinate. But I think that, you know, these problems are fixable. Like you can use the ecosystem libraries in your projects. You can even use them in your code base. Like Scala tree jars are binary compatible across all minor versions, so you can use them and they work. That's what the binary compatibility is for. You want to compile them from source, take the source jar, unzip it, compile it. You want to vendor it so it doesn't collide with other things on the class path. Yeah, just regex the package statements and then compile it then, and then use the regex version. So this is something that I've actually done at Databricks several times. It works okay when necessary. And like, if it would be nice, what the point of this is this will let people who work on Scala, the language, and Scala, the compiler, kind of get more exposure to what's happening in Scala ecosystem. So it doesn't get blindsided by, oh, someone's actually using implicits this way, oh, someone's actually using macros this way. But you'll see it day to day, you'll get curious, you look at it, and people will generally get better empathy and understanding of what the other side is doing. Yeah, so that's what the com-lihaoyi platform needs from Scala, what it is, what it needs today, and what it needs going forward. And I'm done. Thank you.